not unpublished, preview. Okay, let's talk about the physics behind each one. I'm going to give you guys 30 seconds for each one. 30 seconds for the easy ones, more time for the hard ones. Turn to your neighbor and discuss. Not what's the answer. What's the physics? What's the principle? Where does that go? Turn up. Nah, I'll ask when we get to the harder ones. I will. This one should be. Oh, what the heck? Sure, I don't. Yeah, put this in Google Form A. No, put the answer in Google Form A. You should discuss with your classmate what's the concept. But let's restroom. Restroom is the correct answer, actually. Trick question. Okay, tell me the answer. Tell me the answer in Google Form A. Please don't use a calculator. You could do this without a calculator. Divide by 10, baby. You could do it without a calculator. Oh, right. Also, another thing. I want to see no bare numbers unless we're talking about a ratio. Give me units for each and every one of these. How many units?
Why cannot?
I'm gonna say time's up. Correct answer is 0.568 ohms. Hey, please note, by the way, what's the voltage measured in? What's the current measured in? So can the answer be amps or volts? Think about that for a second. If you answered 0.568 amps, meditate upon this. Can't be one of the things that's given. Okay, so concept V equals IR. Duh, yeah, is good. Great, next one. This is something we did a deep dive into this. At this point in the semester, this was supposed to be hard. Now, hopefully, you remember how to do this. What's the current in this circuit? Question B. Okay, the correct answer is basically zero. Like really freaking close to zero. Voltmeters typical internal resistance is 100 million ohms. Million ohms. So basically not a current one. Follow-up question C, half a second. Follow-up question C is what voltage does the voltmeter register? Then I'll take your question. And there's no current in the circuit. How much of a voltage does the ohm meter see? Something I don't know about purple material. I do know about air is either not conducting, break down what is conducting, what is conducting. So that is not that's so no, it's not everything is A light bulb is really decent. A variable is a thing, but you can assume for small changes in current is approximate proportion. Okay. Lots of things, but certainly not everything. Okay, follow-up question. 9 volts is the correct answer. Oh, almost 50%. Let's talk about this. It's been a minute since we talked about these principles. Principles of series meters. Voltmeter has infinite resistance effectively, so there is no current, right? If there's no current, what's the voltage here? No current, I is 0. How much current? How much V when you have I is 0? That's correct. K Money said, whatever your V is here. Yeah. Whatever your V is here. Big point that still a lot of people are missing, at least in the 3 o'clock class, is V equals IR does not tell you the voltage at a resistor. It tells you how does that resistor change the voltage. I times R is 0, which means that this resistor does not lose any voltage. If we start at 9 and don't change, we also that resistor ends at 9 volts. So this voltmeter feels 9 volts of pressure difference across it. Not 0. Just because there's no current doesn't mean there's not voltage. There could be voltage without current. I mean, hell, think about this. You just take a 9-volt battery and hold it up. What's the voltage between its terminals? 9 volts. What's the current that's flowing? 0 amps. There's a voltage without a current. Okay. Anyway, correct answer to this question is 0. 0 current, and if I had asked about voltage, it would be 9 volts. This take 2 minutes. 2 minutes. 2 minutes to discuss. And put her in D if you can. That is how many volts are lost in that resistor. Yeah. Note the units, by the way. I tell you the voltage drop across the top and bottom resistors. That's not the resistance. Note the units, by the way. I asked for current in what? Milliamps. You must be able to convert between amps and milliamps and stuffs. And this answer goes in D, not E, please. D. Okay, it's time for this one. Correct answer is 13-ish milliamps. Here's how you do it. Total voltage in series gets dissipated, right? Principles of series circuits is the voltage you gain equals the voltage you lose through each component. Total voltage adds up. How much total voltage have we got? 7.5 volts, right? 7.5 total volts. How much voltage did we lose here? So how much is left for these two? 4 volts. Well, 2 volts are lost here. How much is left for this? 2 volts are left. 2 volts, 150 ohms. Can you find the current? V equals IR. And then if you know the V equals IR in this component, series currents are identical. You know the currents everywhere. It's all the same. You also must be able to convert. How many milliamps in an amp? 1,000. So final answer, you do this in SI units, you get 0.013. Convert to SI would be 13.3-ish. Okay, that's a couple of steps. Turn to your neighbor and discuss real fast, then I want a question about this. Okay, give me a question. Where are you stuck? Where's your partner confused? Anybody have a question? Yeah, please. So there are 1,000 millas in each amp. If you've got amps, the give millas multiply by 1,000. Millas are smaller than, so there could be 13 millas that make up a fractional. And do the math, I think it will work out to be 0.013 amperes. Convert to millas, 13 millas. Good. Good. No questions? Great. I think that's it. Units of current. Amps. What's the coulomb? What question would be? Oh, there's a question in the chat. I see. Let's see. Thank you, Alex. Where did I get the 2 volts? The people online can't see you pointing. Okay, thank you. So the 2 volts are what happened when you generate 7.5 volts and then take away 3.5 and 2 more volts in the known voltage drops. The two known supplied voltages add up to 7.5. The 2 known subtracted voltage drops, the voltage losses, add up to 5.5. 7.5 minus 5.5 is 2 volts left for the last resistor. Is that more clear? Less unclear? Okay, let me follow up here and ask, awesome, Olivia. Okay, what question would I ask that the answer would be coulombs? The answer is, or the question would be, what are the units of charge? What answer would I ask where the answer would be the third one? What are the units of voltage? What question would I ask where the answer would be the fourth choice? What are the units of resistance? That's right. Good. Follow-ups on any of these? Follow-ups or follow downs? I'll take follow downs. Any follow downs? No follow downs. Okay, I want an equation. Take a minute here. An equation relating these currents. E. Oh my God, look at all these right answers. Oh, you're making me happy, people. An equation has an equal sign in it, by the way. Just telling me some symbols added or subtracted from each other is called an expression, not an equation. Okay, let's discuss this. A lot of people got this right. A lot of people, making me very happy. The principle here, the principle is that current in to any point equals the current out from that point. Let's consider the bottom junction. The bottom junction has I2 pointing towards it and I3 pointing away from it. But what's in the right wire? To figure out what's in the right wire, we have to look at where I1 is in the top right resistor. I1 is flowing to the right in the top resistor. Okay, if that current is in series with that battery, which direction will that current flow in that battery? If you go right, you have to turn down through that battery. This is recharging that battery, by the way. This is the battery charger circuit. So anyway, I1 going to the right down that resistor must also then turn and go down in that battery. Must then turn and go left in this wire. This wire, that top resistor, and the battery are all in series. So what goes into any point along here must come out. Keeps flowing. Current does not decrease. Current does not increase. I1 amps here, I1 amps here. In which direction is the I1 amps flowing in the bottom right wire? To the left. To the left. You follow that arrow around for I1, he's pointing to the left. Okay, so does I1 point towards or away from the junction? Towards. I1 points towards the junction. We've got two arrows pointing towards. I2 and I1 point towards and one pointing away. What goes in must come out. I1 plus I2 equals I3 is the correct answer. Follow-up questions. A lot of people missed this on week 2. Make any more sense now that you got more of an intuition for how this stuff works? Does it make less sense? Yeah. Doesn't matter what the components are, ever. Series components, series circuits, always the same current anyway. Resistors do not lose current. Batteries do not lose current. What will be lost in the battery is energy. As that current flows in the wrong direction through the battery, that current will lose its potential energy, charging the sucker up. But the electrons in have to be balanced with electrons out. Every charge that moves here has to be balanced with the charge that moves there. Deep and powerful principle about electric current. Charge doesn't bunch up, ever. Charge doesn't have traffic jams. Cars in traffic jams get closer together when they slow down. Doesn't happen with electricity. Also, charges don't vanish, appear, reproduce, or die. So every electron that's moving at any rate through this has to be moving at the same rate through all the various components. Good question. Other questions? Please.
So you're saying energy is being taken away.
Yep.
Well, both stays the same as that current, right? Voltage?
Nope.
Or the amp, sorry.
Yep.
The amp stays the same. What's
Yep. Yep. If I knew the voltage at this point, as this current flows through this resistor, the voltage would decrease to this point. As I go from the positive side to the negative side of the battery, I have deposited energy in the battery. As the current flows the wrong direction through the battery, voltage at this point would be lower still. So I have lost voltage and lost voltage again when I go through that path. Yeah, absolutely. Good questions. Last question's about this sucker. Battery. This rustled a lot of jimmies. Do you guys still say that? Do you know what my jimmies are rustled means? No, a couple of people. This bothered a lot of people. Take a minute, discuss it with each other. Yeah, Google form. Which one are we at? F. Ryan, please answer this in F. If I'm looking for a ratio, a fraction of currents, what are my units? It is a ratio of current divided by current. What is the units of amps per amp? Unitless. If I take amps and divide it by amps, I'm left with no units. It is a fraction, it is a percentage, it is a unitless quantity. So do not tell me amps, do not tell me ohms. Piper, that's okay. Try it afresh. Try it fresh. Twenty. 20. Okay, time's up. I started the 3 o'clock section on a problem like this algebraically, and I think everybody died. Not everybody, a lot of people died. Algebra is hard. Let's talk about numbers. I am looking for a total, I'm looking for a fraction of a total current. I'm looking for a ratio. Proportional reasoning problems, you can do the following. Make stuff up. You can always make stuff up. Let's pretend that this current flows because of a 9-volt battery. 9 volts are applied to this. Okay. How much current is flowing through this sucker? 9 volts in parallel, it's the same voltage, right? 9 volts across 9 ohms is 1 amp. How much current flows through here? Trace, 3, 3, 4, da 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 da. 3 amps, right? Okay, how much total current is there? 4 amps. Okay, so again, I'm reasoning about this based on a made-up number. I'm pretending that I know the voltage which is driving this current. If you pretend that there's a 9-volt battery driving this current, this is pulling 1 amp, this is pulling 3 amps because Burr. Total current in is 4 amps, and then I can answer. What fraction goes through the 3 ohm resistor? I said this is 3 amps, this is 4 amps, 3/4. 0.75, done. Questions? Okay, follow up to this. What if I had picked a different number to be the total voltage? you'll end up with the same ratio. The individual current numbers will all be different, but the ratio, the proportion has to balance. Has to be the same. Last chance for follow-ups here. Yeah, please. Absolutely. Tell me. Okay, what would you get for the total resistance? Nope. These are in parallel. Use the parallel formula. 12 would be if they're in series. So if you have two resistors in series, then you add the resistances directly. In this case, you've got them in parallel. So what's the parallel formula? Do you remember? 1/3 plus 1/9. Flip that. What is that? 9/4. 2.25 ohms. So the total here is 2.25, not 12. Now you can reason with this. If you say the total voltage across the total 2.25 ohms resistance generates some amount of current, and then reason about how much does it generate just through here, that ratio still works. But be careful. This is not 12 ohms of resistance. Watch out for that. Yeah, follow up for the gentleman in the white hat. You have a follow up. Yeah. Yeah, 1/3 plus 1/9, 1/9. Good. Okay, last chance. The long lead. This is just knowing some. Quiz dry. Anyone speak German in here? Yeah. Okay. Well, it's one person. I'll tell you the puns later. Okay. Okay, here we go. Take a minute. Find R. I found it. It's right there. Okay, put this in Google Form G. Units. Units. My first foster daughter would always tell us, Dad, he was 4. Dad, I love you 5. And then when she was being a little brat, she would say, Dad, I love you 10. Mom, I love you 5. And at each point, I would send her to her room. Units! Just kidding. 5 what? Very well, thank you. Your charger, oh, there's a diode, a one-way gate. Or a complex circuit which reproduces the effect of the diode. There are components besides the resistor. And one of them only lets correct by one way. My guess is good. Yeah. What's next? Deep dive into what is voltage? Where does it come from? What does it mean? Where? What does it mean if you've only got a single charge in the universe? Is there still a voltage? Anyway. Okay, time's up. Let's see what you guys answered. Oh my God. Ah. Okay, my dudes. What's the total resistance here? I give you a voltage, I give you a current, what's the total R? 42. Careful, not 0.042. 42, that's 0.1 amps is 100 milliamps. Okay, so there's 42 ohms total. What's the series addition formula? It's the easy one. Write down an equation. 42 equals 10 plus 15 plus unknown. Solve for unknown. 4.2 volts, 100 milliamps, V equals IR. Does everyone else see that? Where did I get 42? It is the answer after all. Okay, so I gave you that the total voltage applied to the combination is 4.2 volts. I gave you that the total current that flows, you don't have to say total, it's series. The current that flows is 0.1 amps. V equals I times R tells you the total resistance is 4.2 divided by 0.1 is 42 total ohms. Okay, 42 ohms comes from what? 25 plus unknown? Must be 17, right? Yeah. Follow-ups. $17, if I am not greatly mistaken. Find current through A. I'm gonna give you a 40-volt battery. Find the current through Ra. Ooh la la. Anyway. This is not a bad one to do with your comrades. Turn to your comrade and work this. Turn to your fellow citizen and discuss. Wait, but that doesn't apply to him. Turn to your friend and or enemy. It's not those two products divided by sum. Equivalent to the sum of this over both the sum. Hard tip, if you've got two equal resistances, it's half. Ten parallel things about it right now. You say in Spanish, put this in la letra. Wait, no, you say Ache. Never mind. Whatever. Oh dear. Oh no, 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 it stings and burns. Okay, let's get a counting. Yes, Piper. That's how I always start these problems. Units, Mariana, units, units, Taylor. Okay, I have 12 correct answers right now.
No, it's being resisted by the rest of the things. I see what my logic is failing.
Melissa, Ricardo, read the question again. What am I asking for? Da. Honey and Quentin. If they touch with no other touching, series. If they touch at both ends, parallel. That's it. Okay, we're up to 19 correct. And two big sillies who are using the wrong units. You big silly. How do we measure current, beeps? You're not doing the thing. Got several people telling me that they're 4 ohms of current. 2 people.
What are you doing? Amperes?
Amperes. Amperes. I know a lot about the electricities. Here's the amperes. Amperes. Wait, did you take French? Oh, okay. Do you take French? How would you pronounce Ampere? I can't do the guttural R.
It's like,
And I put the R in the back of the
days
throat.
when you come back.
Yeah.
And on French.
See, my shoulders and okay. I like to count to 10.
What's the song about fluffy wheels?
That's more than I know in Arabic or Romanian. So.
You know both. Is that the one?
I took both. I got decent in German. I got decent in Spanish. I took Arabic, Romanian, and I picked up like an expression here and there. Probably. And I speak Morse code. The sexiest. Morse? Hey, favorite. Where'd you learn it? Boy Scouts? Nice. Very cool. Time's up. Okay, this has multiple skills. Multiple skills. Make note of where you fall down. You must, to solve this problem as well as a bunch of others, you must be able to identify series and parallel. Let's take a second. How do we see series? Define series, it's when two components touch without a third touching there. Two components touching without a third component touching there. The connection is only those two. Two components are in parallel if they touch on both ends. B and D are not in parallel because C gets in the way of their tops. A and C are not in series because B breaks that series. B is also involved in that connection. C and D are in series because where they touch at the upper right has no third component there. What's the series addition formula? 5 plus 5 is 10. Now the combination of CD together, CD's this side touches B, CD's that side touches B on the other side. CD is parallel to B. 10 parallel 10 is 5 again. BCD is 5 ohms. BCD is connected in series with A. 5 plus 5 is, hey, 10 again. It's as if I chose these numbers to be easy. Okay, so what's the 10 represent? 10 ohms total resistance. What do you get with total resistance? Hopefully a total revolution. No. You've got total resistance, you got total voltage, 40 volts, you get total current. 40 volts, 10 ohms, 4 amps. 4 amps where? When I say total current, I mean what's the battery supplying? 4 amps leads the battery. How much goes through A? Principles of series. 4 amps flows through A. Correct answer is 4 amps. The biggest goof is to tell me 40 volts touching 5 ohms is 8 amps. About a quarter of you told me 8 amps. If you said 8, reflect on this. Reflect on this, my comrades. Reflect on this. New problem, new problem. Clear your mind, clear your mind. Just think about this. I start going at 100 miles an hour. Fine, Jesus. I start going at 10 miles an hour. I accelerate for a second, for 1 second. Oh, I'm really stupid to get 5 miles per second, 5 miles per hour in each second. Okay, so I start at 10 miles an hour, and I accelerate by 5 miles an hour per second for 1 second. What's my final velocity? 15. What people who said 8 amps are doing is they're saying acceleration is velocity divided by time. Velocity is acceleration times time. No, acceleration is not velocity divided by time. What is acceleration? It is change in velocity divided by change in time. V equals IR does not tell you that the voltage at a resistor equals current times resistance. You cannot say this guy has a voltage of 40 volts. 40 volts divided by 5 ohms equals 8 amps. Why? Because the difference in voltage from one side to the other is what causes the current. As it works out in this problem, the difference is 20 volts. That actually takes a little bit of reasoning to get to. That takes a couple of steps more to get to. But you can't use V equals IR directly with this resistor unless you know the voltage change from one side to the other. So how did I do this problem? As I demonstrated out loud, you find the total resistance by doing series parallel combinations. When you have the total resistance, you could use the total voltage and total resistance to get the total current. And what I asked for was the current through A, which is the total current. He's in series with the battery. Turn to your neighbor and discuss. Particularly, I want you to discuss not just why the answer is 4 amps, teach each other why the answer is not 8 amps. And I'm going to ask you to ask me a question after this. I have an answer.
Again, specifically, A. Yeah. The battery back.
What? A resistor is never going to give you more voltage. So whenever I say the voltage across the resistor, I'm talking about how does voltage decrease as it goes, as the current goes through. Actually, that's a lie.
Never give you.
No, it's not. It's not. It's always true. A resistor will never, as current flows through a resistor, it will never increase in voltage. Ever. Amplifier works by using, for instance, a transistor where there are 3 things. The transistor, it's not input and output, it's input, output, and control. That you would do for an amplifier, so you're controlling of your microphone. The microphone has a low volume signal, and that wiggle is controlling the low volume. Does there is a resistance that is out. So you've got a resistor, varying with the signal. With that, is you got a wiggling resistance. You hook this up to a big honking battery and loudspeaker. The battery drives a big current in, so now that current goes up. That current goes down. So we've got the battery attached to the collector emitter, which is allowed to control a much larger current than the input. The input doesn't take much energy at all. Output energy comes from the battery and then modulated. Sort of like the transistor affects the resistance inside. It's the short thing.
So
We don't get into it in this class.
resistor.
Ask me, come through one of my lab sections sometime. You're not in my lab, right? Yeah, come through one of my lab sections sometime, figure it out afterwards. I've always got, I can show you. We got transistors. I can show you the way.
Resistors, whatever you see.
Yep.
Also energy.
Yep.
If you heat up the resistor,
Nope.
it won't cause voltage.
Nope,
Nope.
nope, nope,
Don't go nowhere.
nope.
He goes out, you're gonna put heat back, nothing.
Correct.
Yeah.
There are components that you can transform some heat into a little bit of voltage called thermos. That interaction, God, I don't even remember for this my life. There's something interesting in that.
I did the same thing as a big little non-freon fridges.
Yes, the icy ball.
Yeah.
Or
we got
no,
the-
Uh,
One side gets really cold, one side gets really hot.
There's something to that, but I don't know. Einstein actually invented that, I think. The icy balls refrigerator. It's neat. There's neat chemistry inside. Okay, ask me a question. No, no questions? Next one? I. Comrades, I, Captain. Please reflect on what I just told you about the voltage present at one end of a resistor. Yes, 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 no. Yes, no, no. A lot of yeses, though. Units, units. How do we measure currents? Units. Hey, here's a transistor. Take a faucet. And it has a really big lever for the faucet. Thank you. Then shoot a little stream, little bit of stream at the paddle, the lever paddle. The little stream of water could turn on and off the big flow in the faucet. Yeah, you got a huge long lever arm, and it only takes a little bit of force to torch the heck out of that thing. So a small input control current can make a big effect on the resistance of the faucet itself, leading for a huge current. Okay, time's up. Correct answer is not 2.5 amps. The wrong answer is 2.5 amps. How did people get 2.5 amps? They took 10 volts and divided by 4 ohms. Girlfriend. Is that appropriation? Should I not do that? Whatever. Okay, 10 volts is not applied to 4 ohms. 10 volts is applied to the whole circuit. 4 plus 6, 10 ohms. 10 ohms is subject to the 10 volts of battery. So when 10 volts is applied to 10 ohms, how much current flows? 1 amp. Hey, what's the voltage at this point relative to ground? How would I find that? We just reasoned that 1 amp of current flows through the circuit. How can I find the voltage here? Perfect. Subtract the voltage loss. V equals IR says 4 times 1 is 4 volts difference. 4 volts change in voltage. And it's always going down. In a resistor, you're always going to lose that voltage. If I start with 10 and change by 4 times 1 is 4, I'm left with 10 minus 4 is 6 volts left relative to ground. Olivia, you asked 10 volts is applied to the 6 and the 4. The 6 and 4 together feel 10. If I asked the current in the 6 ohm resistor, yes, it's in series. Series is the same current everywhere. Yes, 1 amp everywhere. Last chance for follow-ups here. Alex, follow-up. You have a thought. Oh, your hand is. And you get a question, and you get a question. Okay, I just answered this question with 1 and 3 Sorry, 3 and 9. Is it okay if I skip this? Parallel current fraction. Yeah, is good. Da, igen. Da 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 da. Ah, here's a one. Here's a second. You have 1 minute to answer this sucker. J. Or just do it. Tell me the series, parallel, neither, both. Yeah, let me embiggen this. Oh, people remember what I said 5 minutes ago. Very good. Mostly. 1 amp is not correct. Haneen, the only thing that is both series and parallel at once is just a single battery connected to a single resistor. They are connected with no junction. They are connected at top and bottom. All right. We are at 95% correct. The correct answer is neither. Neither series nor parallel. Why ain't it series? B. Why isn't it parallel? The battery and D get in the way of the other end. Again, why isn't it series? We define series as the point that they touch has no third thing touching. Hey, look, this touches. Oh, no touching. No. We define parallel by touching at both ends. A's right and C's left touch over here. A's left and C's right do not touch with wire. There is no wire connection between C's right and A's left. So not parallel, not series. Question. If the resistor were here, if there's a resistor here, that is in series with the battery and in series with A. Yeah. Good. Okay, that's 3. Let's do 4. K. K for K money. Yes. Yeah. You know something that Alex told me that some people are still struggling with. Which way is up? If you've got a piece of paper, which way is up? Towards the top of the page. Got a piece of paper. If I don't tell you cardinal directions, north, south, east, west directions, up means towards the top of the page. If I tell you cardinal directions, which way is up? No. Up is up. Up is away from the planet. If you've got cardinal directions, I've got, I don't know which way is north in this room, but north, south, east, west are around. Right angles to that. This is up. This is down. So if I give you a problem with north, south, east, or west, you imagine yourself standing somewhere and looking around, and which way is up? Up is up. Imagine the scenario, and you'll do better at it. Scenario. If you were looking at a piece of paper, if I talk about in, out, left, right, up, down as the coordinates, then up is towards the top of the page. Out is pointing at you, in is pointing away from you. Left and right or left and right. Yeah. I can stand them. Okay, let's see what people have come up with. Yay! People got it right. Yep. Yep.
So with the needle rested.
So it's the charge in a needle is actually spiraling, is not spiraling, it's circling around the compass needle.
Oh, so
That's
it's
circular motion.
always forward.
Well, there's a torque, and a circular motion,
It just
pivoting around.
balances right there.
It's more complicated. So I should say, actually, no, you don't have a single charged particle moving in a single direction. You have charges moving around the needle. Okay, so let's work it out. You get a gift. Show me your gift. Everyone gets a gift. Flip off the odds, gave it to you. Now freeze those. Oh, and stick out your thumbs. Go hitchhiking. Then go hitchhiking. You're hitchhiking to go away from your own house because you get such crappy gifts. Now freeze those fingers and don't you dare move those fingers. Those fingers say stop. Q V cross B. What's the first finger? First finger is the V finger. Which way is V? Up. Which finger is middle finger? B finger. So put your middle finger towards the right. Which way is your thumb sticking? Don't use the left hand. Right hand. So make a triad. Get your hip. Flip them off. Stick out the thumb to anything. Right. There we go. First finger stays like that. First finger stays like that. First finger stays like that. There you go. Which way? See if you have flip flop. Right? These are your three fingers. First finger is the velocity finger. Middle finger is the field finger. So rotate your hand so your first finger is pointing up. First finger points up. This finger points up. Your arm needs to be pointing up. Now your wrist is going. There you go. No, now you're going like this. Up, like it up. Okay. Now the middle finger is the field finger. Turn your arm so that your middle finger is pointing this way without changing which way your arm is pointing. So rotate your arm so that your middle finger is pointing like this.
We have.
You decide the confidence level. You need to rotate your arm so that your middle finger is pointing this way. Is that the figure also?
They don't want us to be
There you go. Try to figure it out. Okay, so if your middle finger points right, and your first finger points up, then you kiss it forward.
Equally.
So, I got this.
Oh. I practice the properly and then flip it. See what's there. Question dose. I'll wait. 1, 2, 3, eyes on me. What else do you not say in college anymore? Okay. Okay, make your triad. Give me your fingers. Give me the fingers. Now, freeze your fingers. Your fingers can't move. Keep your fingers the way they are. You can only move your wrist and your arm. Yeah? Move your wrist and your arm however you want that doesn't smack your classmate. Depending on how well you like them. Now, I want you to point your first finger in the B direction. Now, without moving your fingers, without rotating your fingers, I want you to point the middle finger downward without moving the first finger. No, your first finger moved. Right, the first finger pointing up, the middle finger pointing downward, and this staying at a right angle is contradictory. If one finger points up and the other finger points down, there can't be a right angle between them. Zero force. Right hand rule does not geometrically work. You cannot point up and flip off the bird downward at the same time with your fingers frozen. Zero force. Go back and reread the slide one in the slide set. When magnetic field is perpendicular, you get a force. When magnetic field is parallel, no force for you. Yeah.
So when it's facing, the thumb is facing away.
So the in out is with respect to these things. If you're pointing toward the paper, that is pointing in the paper. Not you. You are not me. I don't care about you. I care about you. Okay, I will remain and take other questions, but I'm gonna say class is done. You can get out of here if you're mentally exhausted, get out of here. I'll stay until either my wife kills me or people are done asking. He has 3 small mammals that she's juggling at once. It's hard.
Sorry. I had a question. Yeah, this.
Yeah.
What is this having to do?
Okay, so which direction is the force on 1 and 2? Direction.
Assuming it's gonna come in.
Nope. Which direction are they turning? They're turning upward.
So
So the force is up.
force being
Force is your third finger, your thumb.
the total for, okay,
Okay. And which way is the velocity finger?
velocity is points,
Yeah, and which direction are they going?
that one.
Yeah. Which direction is the field finger?
In.
Wait a second, but these are outfields. These are not positive forces. V cross B would be down.
Oh, it's looking at us because it's the tip of the arrow.
Yeah, the tip of the arrow is shooting out, but should point you out of the eye.
So,
Okay.
so technically, because it's,
Kaylin, half a second.
so it's, these are the negative,
Yep,
This
has
is
to.
positive?
It's the only way.
so this is the fastest. These are,
For
That's-
speed, you have to use the formula radius equals mv over qb. Which of these has the biggest radius of curvature? Which one curves the least intensely? That's mv is biggest, v is biggest because r is biggest for 3 is biggest, yeah. 3 is the fastest because r is
the
the
only
only,
positive. Okay,
but that doesn't depend on
that
sign.
depends about
Yeah.
the radius. Okay, thank you.
Kaylin just asked, is lab in person this week? Yes, come to lab, work the problems with your classmates and juice them for knowledge. Juice the questions for knowledge. You may or may not wish to juice your classmates for knowledge.
Can you explain this just one more time?
This one?
Yeah, this one.
Okay, make your triad. Okay, don't freeze your fingers. They cannot turn, only your arm can turn. Point both up with this finger and down with this finger.
Up with this finger?
Up with this finger, down with this finger, simultaneously.
I can't.
Exactly, you can't. There's no force on a particle moving along the direction of the field lines.
Okay, so this would be Q. And like.
V.
Or V, yeah.
And B.
Okay.
Can't simultaneously happen.
Okay.
No force.
Because I was worried. Okay, makes sense. Thank you.
What do you think for Clark sign? Oh, this one next. I'll just.
Fine.
Sign. Fine.
Did I ask about the? I did not ask about the mic. Okay. If I'm giving you an angle and ask for the magnitude of the magnetic force, you would have to use trigonometry.
Oh.
For this, for this, there's a bit of it going left. That leftward motion is not affected by electric field. So we only care about the fact that it's slightly going up. V up, V left,
Oh, so
V cross B is which way?
oh no, out. The paper.
But he's negative.
So it doesn't have
So
to
they're,
be.
so magnetic velocity up.
Going at a diagonal is both going some perpendicular and some parallel. If I walk northwest, have I gone some north? Have I gone some west? So there's still northward motion, there's still upward motion, there's still perpendicular motion. Even if not all of the speed is carried that way.
Second, I missed it.
Okay, I missed it.
No. I will give you right angles on the test.
Oh, it's spiral.
Thank you.
Yeah, that's
Do that. Thanks.
Right.
totally. Questions, 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 questions.
Do you need to stop recording?
If I get questions, I don't. Wait, let's see, are there any questions in chat?
This radius is the fastest.
Yep, and V over QB is biggest when V is biggest. Radius is MV over QB.
Okay.
M, Q, and B are constants.
Okay.
So we don't care about them. So you get the biggest V, gives you the biggest R. Fastest particles need the biggest radius to curve around.
That seems.
Yeah, because they're
I
making one
assume.
full cycle at the same amount of time, so.
No, they don't make it the same amount of time.
Okay.
They have different times. Cyclotron radius is different for different speeds. Wait, is it? Wait, no. Is that true? Fred, what's the cyclotron frequency formula?
We have.
I don't think it's the same time, but I actually would need to run the calculation. I don't think they make the same.
Is, what was it? Distance.
Ding
over
dang it,
velocity,
I have to work it.
And then the distance is 2 pi r, but r is just v squared over r.
A is V squared divided by R.
Just be squared over R if it's gonna be R.
What is r? Radius equals.
Happens to be.
So the radius of curvature for cyclotron is MV over QB.
mv over qb.
David gets a feature on yours, welcome tonight.
And also write bigger so the recorder can see. R equals MV over QB, that is certain.
And then if that is, if this is the r. Then distance over velocity.
No, it's just over time, this is over time, that is distance.
Solving. Oh, yeah. So 2 pi x.
Just cancel. Well, it does cancel.
QB
No. You're right, it does cancel, I'm wrong.
equals
I'm
the
wrong.
time.
I'm wrong, you're right, they do curve in equal time.
That's why the radius has to be the fastest of all.
One more to do it.
Which whoever replaces r with mv over qb is insane.
Well, you can get that.
Just put r and b. But
But if you don't know R, then.
I mean, you can solve it with, but yeah, sure. If you have e's and you have r. Just know. Or do you?
You're right, the same frequencies with different energies. Okay, I think this constantly in every thing. Right, cyclotron radius bending formula is.
Wait, so
more than
the
one.
time, the time to complete a circle isn't dependent on the speed?
Correct.
That's.
Smaller circles go with less speed. Their radius of curvature is easier, the magnetic field finds it easier to bend them around.
Oh, this is the whole what spins faster, the inside of a wheel
That's
or
right.
the outside of a wheel? Ah. Alright,
Very nice.
Other thoughts, questions, comments?
Jameson,
No,
you gonna be
thank
taking the
you.
test with us?
Oh,
You should do it, no, come on, do it. Dude.